Hello again. This is Professor Rowley. Hello class. Hello students. This is Math 120 section 5.2 number 2. And you'll notice that I circled something on number 2, and that's this x is greater than or equal to 0, y is greater than or equal to 0. Now, what we're going to do is figure out what that means. And so if I look on paper here, number 2, everything's pretty much the same except for this x is greater than or equal to 0, y is greater than or equal to 0, and that comes up quite a bit. If we graph this, we are looking at where x is greater than or equal to 0, y is greater than or equal to 0. Now if I look at x is greater than or equal to 0, x is equal to 0 is, let's see, what is that? That is the x-axis. So x is greater than 0. I'll use a different color. Unfortunately, it's hard to see because it's going to be right on the axis. That is x is equal to 0. So every point on here has x is equal to 0. Remember, x equals 1 was over here, x equal 2. Well, x equals 0 is every point on this line. Now, x is greater than 0 and equal would be everything this direction. All right, so that is x is greater than or equal to 0. This line and everything to the right. Y is greater than or equal to 0. Well, y equals 0 is this horizontal line. Everything on that line is y is equal to 0. Kind of interesting that the x-axis is y equals 0 and the y-axis is x equals 0, but that's the kind of world the math world is. And y is greater than or equal to 0. Think about it. Every point on here, x is different, but y is always 0 on that line. And y is greater than or equal to 0 would be everything above the x-axis. Now, where these two inequalities intersect is in this quadrant. This is just purple, neither purple nor red, just red, and this is purple and red. So we are talking about this region here. So when we are looking at x is greater than or equal to 0, y is greater than or equal to 0, we are looking at what we call quadrant, Roman numeral 1, quadrant 1. So if you remember from your algebra days, this is quadrant 1, this one is quadrant 2, this one is quadrant 3, traditional to use Roman numeral, and this one is quad 4. All right. Whenever you see x is greater than or equal to 0, y is greater than or equal to 0, we are talking about everything in quad 1, quadrant 1. And we won't even consider graphing in these three quadrants, especially with all the applications that we are going to be doing. Everything is going to be positive in our world, at least in this class. Now, one thing I want to say, note that every ordered pair in here is positive. Positive, does that make sense? So you go to the right, positive, up, positive. So everything in quadrant 1 has a positive x and a positive y. And that's what greater than or equal to 0 means. Greater than that's positive, positive. And quadrant 2, if you think about this direction, would be negative, positive. This one's negative, negative, and this one is positive, negative. So the only quadrant in which both x and y are positive is quadrant 1. So what are we going to do with that information? Looking at this problem, I would look at this information here and say, well, we're talking about graphing only in quadrant 1. And so I won't even look or draw anything in this quadrant or this quadrant or this quadrant. I'm only going to graph in this quadrant. What am I going to graph? These two inequalities. So these restrictions here, or constraints, just put us in quadrant 1. All right, so let's graph these two inequalities only in quadrant 1. So number 2 we're going to graph 2x plus y less than or equal to 4. This is solid. I'm going to look at 2x plus y equals 4, graph the intercepts. Okay. When x is 0, what is y? Well, if I put 0 in here, one thing that you'll get used to, if you let x equal 0, it wipes this term out, and you get y is equal to 4. Okay, so that's a little trick. Or you just plug in 0, and you get y is equal to 4. And now I'm going to plug in x equals 0. So 2x plus y equals 4. I'm plugging in y equals 0, so you can do x plus 0 equal 4. So I get 2x equals 4. X equals, divide both sides by 2. X equals 2. And, you know, you can stop this video and slow it down and back it up if you need to, if I'm going too fast. That's the beauty of a video. I don't know how beautiful this video is, but hey, it's the best I can do right now. So 0, 4 over here. And 2, 0. And because this is restricted to quad 1, I'm not going to go beyond the axes. I'm just going to draw the line right here. That's it. Because we are restricted to quadrant 1 based on this, so nothing, I'm not even going to consider anything over in these 3 quadrants. Nor am I going to extend my line in any other quadrant. Now I'm going to test 0, 0 into my inequality. And is that true or false? It's true. So we're going to shade on the side of 0, 0. Now come over here. And I'm going to shade on the side of 0, 0. Here's 0, 0. So this side gets shaded, but I'm only going to shade to the x-axis, like that. Notice I'm only shading in quadrant 1. My x and y are restricted. Because look at this. Everything's restricted here because of this. So now all I do is do my shading in quad 1. Let's look at the second equation. That's the one up here. X plus y less than or equal to 3. The one we just did was purple. And again, yes, I did show those intercepts. So let's look at the next one. It's x plus y is less than or equal to 3. This is going to be solid, and everything we do from now on will be solid, not a dotted line. I'm going to graph x plus y equals 3. Put in my intercepts. Now again, if I let x equal 0, what do I get for y? So it just wipes it out, and I get y is equal to 3. If I let y equal 0, that gets wiped out. And what do I get? X equals 3. So I have 0, 3, and 3, 0. Let's go plot those. 0, 1, 2, 3 right there. Just put 3, and then 1, 2, 3 right here. And notice that I'm trying to remember where those values are. I'm going to draw my line. Straight edge would be nice. So those of you, make sure you have a straight edge out there. Because of my camera holding, I'm going to have to be steady here. There. And now you can see, I'm pretty good at drawing these, that you have a little bit of purple in here too. Make sure you see that purple. If not, you can draw another line maybe. Okay. And also, you've got purple here, but there's no purple in this little spot right there. That's open. So I'm going to draw a little bit more purple. Okay, there we go. Make it clear where that purple is and where it's not. I still have to test. I'm going to test 0, 0 in my inequality. This is true, so it gets shaded on the side of 0, 0. So I'm going to shade on the side of 0, 0, and I'm going to turn my sheet right here. And I'm going to draw, kind of like this. Just go all the way up to the red line. Try to ignore the purple if you can. And there we have it. So in here you have just purple, purple and red, just red, and out here you have no purple or red. So where the two colors overlap is your feasible region. And I'm going to make that a little darker. Okay, just to make it clear that that is the feasible region. And I'll draw that that's the feasible region. Now, notice that this, okay, so we're done with part A. It says graph the feasible region. B says find the corner points. Well, look at this feasible region. Usually I would ask in class, how many corner points are there in the feasible region only? There's one here, there's one here, there's one here, and there's one here. There are 4 corner points to this feasible region. Okay. Think of that as a room. We're not considering the others, just the feasible region, just that 4-sided figure there. And these are the 4 corner points. So I'm going to answer part B, which is asking what are the corner points. And some of the corner points are clearer than others. For example, this one. Name that corner point. Yes, 0, 0. What about this one up here? That is 0, 3. Okay. And this one, that one we have to work on. It's not clear, depends on how pretty your picture is. And then this one that's at 2, right? We even wrote 2, 0 before. This is 2, this is 3. So 3 of them are pretty obvious. So I'm going to write the 3 obvious ones. So 0, 0. What's the other one? 0, 3. Make sure you put those in the right order. 0, 3. And 2, 0. So those are the 3 obvious ones where you can get from the picture. But the one there is not as obvious. So a lot of times I'll call this point A. Okay. And we're going to look at how do we find point A. To find point A, it is the intersection of the purple line and the red line. Okay, so here's the purple line, and here's the red line. It's where they cross. So point A is the intersection of the red and purple lines. Now, do you remember how we did that before? We took the purple line, which was that first one, was a 2x plus y equals 4. And the red line is x plus y equals 3. And what do we do with them? We put them in a matrix. and did RREF on the calculator. Now, last time I didn't have my calculator readily available, but I have it now. So let's see if we can do this. I'm going to turn this on. That was the last problem. So I am going to go to, remember, second matrix right here. So second matrix. And then you go to Edit, Enter, and this is a 2 by 3. And then I put in 214113. I've already got that in there. Quit. Then you have to go back, second matrix, back to matrix, math, and then go down to RREF. That's RREF. Enter. Then you have to go second matrix, A, enter, and that gives us, I'll write this down, 101,012. So that's what I wrote down. What does that mean? This is x equals 1. This is y equals 2. It's the ordered pair 1, 2, which is that intersection over here, point A. So if I come back over here, this is the ordered pair 1, 2, right there. That's my point A. So now I have all my corner points. What are my corner points? My corner points are 0, 0, 0, 3, 2, 0, and 1, 2. I'll even put that up here with the rest. So to show that we have 4 corner points. And the last thing we have to answer is bounded or unbounded. Is this region bounded or unbounded? Is it bounded by all sides or not? It is. It is bounded by all 4 of these sides. There's nothing escaping like over here where it's spilling out. So we would call this a bounded region. So this is bounded. All right, that's problem number 2. I'll be back for problem number 3.